We're going to look at how to find vertical asymptotes and holes on a rational function graph. If we were to graph this graph on the graphing calculator, this is the graph that it would look like. A couple things that should stand out to us. There's a vertical asymptote when x is -2, which means our function is never going to be at -2. X is never going to equal -2. So that's one thing that should stand out. Another thing is this point right here, it kind of skips over that point. If you notice, x never equals 3. So let's see what in the equation could have told us that. It's harder to see in this form, but looking at this form, remember we're never allowed to divide by 0. And if x is 3, 3 minus 3 is 0, that's going to give us 0 in the denominator. And if x is -2, -2 plus 2 equals 0, and we're dividing by 0. So we can find where the function isn't going to exist by factoring the denominator and setting the denominator factors equal to 0. One other thing that's really important to notice, they look different on the graph. One is an asymptote, and one is what we call a hole, where we kind of jump over the point. So how could we have told from the equation which one was going to be a vertical asymptote or which one was going to be a hole, or if they were both asymptotes? Well, if you look here now, whatever factors cancel, so whatever factor was in the denominator and it's no longer there, that's going to be a hole. So 3 was the hole. And then any factors that are still left, x plus 2, and that gives us -2 when we set it equal to 0, that's going to give us a vertical asymptote. So to summarize all of this, to find vertical asymptotes and holes, you want to first factor the denominator and set the factors equal to 0. Those points give us undefined points where the graph doesn't exist because we're not allowed to divide by 0. These undefined points look like holes if the factor cancels, and to find the y value of the hole, plug the x value into the reduced equation. So we didn't look at that. We knew that the x value was going to be 3 because that was the one that canceled. But to find how high up that hole was, we could plug 3 in for x in the reduced equation. So 1 over 3 plus 2, that's 1/5. So the coordinate of the hole is 3, 1/5. And the undefined points are vertical asymptotes if the factors don't cancel. So one more quick example, if we were given a function and we had to come up with vertical asymptotes and holes on our own without knowing where they were going to be, we would first start by factor the numerator and denominator to see if anything cancels. Remember, they need to multiply to that number, add to that number. X plus 3's cancel, then write out your reduced equation. So x can't equal -3 or -1 because when we set those factors equal to 0, that's what gives us 0 in the denominator. But the x plus 1 was left, which means that -1 is a vertical asymptote. And the -3, this canceled, so that's going to be the x value of a hole. And to find the y value, plug it into the reduced equation. That's 0 over -2, which is 0.